Now, our second speaker in line is Mr. Ramkumar, Director of Product Management, Techcello. Mr. Ramkumar is the Director of Product Management at Asture Software and has been instrumental in incubating and bringing to market two new products, Techcello and Synergita. And today he's going to talk on different approaches to build a multi-tenant SaaS application. I welcome Mr. Ramkumar.
Talk about the cloud itself, the infrastructure, but this is focused on the application side, the SaaS part of the cloud. So suppose if you are a enterprise or an ISV trying to build an application for the cloud, okay? So how do you build it? What are the various ways? What are the various approaches that are available today to build your application for the cloud? But there are two more aspects to that. One is SaaS, another is multi-tenancy. So there are three things interrelated: cloud, SaaS, and multi-tenancy. So how do you build a multi-tenant SaaS application for the cloud? Okay, what are the various approaches? That's what you're going to cover today. So before that, let me talk about what is SaaS without multi-tenancy. So you typically have a separate server instance for every tenant. Multi-tenant means a tenant means is a customer. Let's say you are providing a performance appraisal system for your customers on a SaaS model. Then every organization is your customer, and so every organization that you sell to is a tenant. So you can actually have a web application which is running on the cloud, offered as a service to your customers, but you have a separate server instance, an Amazon instance or a Rackspace instance or an Azure instance for every individual customer. So that is what is called as SaaS without multi-tenancy. Whereas in a multi-tenant SaaS, what happens is that the same instance, the application instance or the database instance, is shared by multiple customers, multiple tenants. Okay, so that is called as multi-tenant SaaS. So there are various maturity models in SaaS. The first one and two is what I explained, that there is a separate instance for every customer or every tenant. Whereas in the third and fourth cases, a common instance is shared by multiple tenants or multiple customers. And when you have a maturity model of 4, you actually have a load balancer. So you might, let's say you have 1,000 customers, you might have 3 instances serving 1,000 customers, and the load is balanced through the load balancer. Okay. So this is something that you have to decide at your application level, whether you are going to build an application which is going to be in maturity model 1 and 2, or are you going to build an application in maturity model 3 and 4. Now whatever I am saying applies to both new application development, as well as to migrate existing applications. Suppose you already have a product. Let's say you already have a software that you are selling to customers on an on-premise model, where you install the software in customers' premises and they operate it, and you want to move it to the cloud or SaaS. Okay, so in that case you are migrating your existing application to the cloud SaaS. So you might move to the cloud, then you may move to SaaS, and then finally you may move to multi-tenancy. Okay, it's not necessary that all the three should happen at the same time. Like for example, you can take an application, host it on the cloud, it becomes a cloud hosted application. You can still license it on a perpetual basis. That was perpetual license you sell to the customer, but you host it on the cloud. Then you offer it on a SaaS, a service model where you charge per month or per year. Then you are offering it on a SaaS business model. But then whether your application is multi-tenant or not is more of a technological issue, not a business model issue. So you can have a SaaS business model without multi-tenancy or with multi-tenancy. Okay, so the multi-tenancy has a lot of advantages in terms of cost saving, the hosting cost, the production cost, the administration cost, and particularly when you have to service different customers will want to customize their application to suit their requirement. So the general tendency is to customize the code for every customer, because it's anyway you have a separate instance for every customer. So you end up maintaining a lot of code bases. Whereas in a multi-tenant model you can't do that, because it's a single instance, single code base servicing multiple customers. So you have to find other ways of customizing the application without changing the code. And you can also leverage on the cloud elasticity only when your application is multi-tenant. If it is not multi-tenant, you can't really leverage on the elasticity of the cloud. Okay, so here is a summary of 3 broad approaches to building a multi-tenant SaaS application. The first approach is very similar to you have a provider like force.com, for example, okay, and you're building an application on top of force.com, or you're building an application on top of, let's say, Orenscape. So that is the first model. So the APaaS is the application platform as a service, the PaaS is the underlying deployment management automation model, and then the infrastructure as a service, it could be Rackspace or Azure or Amazon. So you use this stack to build your SaaS application, which is the green one. Then you get to the market faster, but there is always a lock-in with the platform in which you are built your application. And the development environment is often proprietary, like force.com has its own development environment, Orenscape has its own development environment, etc. And most of this is 4th generation approach to development. We will talk more about it as we go into this presentation. The second alternative is you do a ground up development of a normal application with multi-tenancy, and you host it on an IaaS like Amazon or Azure or Rackspace or NetMagic, wherever. Okay, so you have a lot of freedom, flexibility and control because the application is fully developed by you, the whole stack is owned by you, and you only hire the infrastructure to run it, right? But there is a lot of complexities and costs and time overheads in getting to the market and offering that as a solution to your customers. The third alternative is to use what is called as a multi-tenant SaaS application platform and then host it on an IaaS or a PaaS or on-premise, because some customers, if you are an ISV building an application, some of your customers will want it to be hosted on their own premises, in their own servers. Some large customers. Some customers, medium-sized customers would want to host it on somewhere else. You can have thousands of small customers using it from Amazon, for example. So, but you still want to maintain a single code base. You don't want to have separate code bases for each situation. So you need to build an application on top of a multi-tenant SaaS platform, which you can host it on-premise or on Amazon or Azure, anywhere you want. Okay. So that is the third approach. So before I go into the advantages and disadvantages of each one of those three alternatives, this is a result from one of the surveys that Techcello did. So typically people today, even because most ISVs are already existing ISVs, they are already on Java, they are already on .NET, so they generally prefer to continue using the same application platforms even to build applications for the cloud. Okay, so that's the preference, .NET, J2E, other 3GL languages, whereas the preference for 4GL visual type of rules or proprietary development environments like force.com is much lower. This is the response that we have got from ISVs who are building multi-tenant SaaS applications. So the development approach is again between building their own layers of application, multi-tenant application layers versus using a hosted platform. The preference is again to build their own or use their own layers. So why do they prefer that? Okay. So as I said, the advantages I already explained. The many of the complex requirements that an ISV needs in its application or in its product is very difficult to achieve in a proprietary development environment. You might have to do a lot of work around with additional coding. If people have used MS Access in your earlier part of the career, you'll understand the difference between using a form wizard and a table wizard to create an application vis-a-vis going to start using macros and VB code to customize it further, right? So most of the visual development tools, application PaaS tools on the cloud are very useful for long tail applications which are simple in nature, which you can just drag and drop, build your model, build your forms and go and host it on the cloud and start offering it as a service. But when you want to make it a little more complex, and you need to really start writing a lot of workaround code to get the flexibility and control that you need, which becomes a little unwieldy. It's like beyond a particular point, an Access application with a lot of macros and VB code becomes unwieldy. So you have to go back to building your ground up application. So there are certain situations where the 4GL approach to building applications on the cloud is very useful, particularly for citizen developers, business analysts who want to build applications for their own departments. Whereas there are always applications that have to be built by standard Java developers or .NET developers, where that kind of flexibility and control you need in certain applications. So you need to choose What is the application you're trying to build? What is the flexibility and control that you need? Whether you can build it on a alternative one type of APAS 4GL type of an environment, or do you need to do a .NET or J2EE based development? There is another approach that is available, which is called as build your application, or take your existing application and host it on a application server. SAS Grid or Apprenda, SAS Grid is Apprenda SAS Grid is one of such example, where it's a runtime platform, it's a runtime environment, where you drop your application into that and it injects multi-tenancy during runtime. Okay, so that is another approach. It is very useful for migrating your existing .NET application to a SaaS model quickly, very fast. But if you have not provided for customizability and configurability in your existing application, you will not get that even after you have hosted it on a SaaS server. What I mean by that is that, for example, if different customers want different business rules, different workflows, different views for their application, but you want to have a multi-tenant application, then you need to have a lot of configurability in your application at the application design stage itself. If that is not there, then even hosting on a SaaS server like this is not going to be helpful. Okay, the third last alternative before we go to the actual cloud-enabled multi-tenant application platform is normal ground-up development, where you fully build the entire stack from ground up, right from your plumbing and auditing and logging and everything to your business features and functionalities. Now the interesting thing about this is, in a typical .NET on-premise application, a desktop application or a client-server application, the overhead between the business functionalities and the non-functional requirements is something like 90% 10% or 85% 15%. Okay, but when you go to cloud, SaaS and multi-tenancy with a lot of configurability, customizability, where different customers have to use it, different customers have to customize it, but you still have to maintain a single code base, the overhead of non-functional requirements, which is not your business functionalities but anyway you have to build, is almost like anywhere between 30% to 50%. So when you build a multi-tenant SaaS application ground up on .NET or on J2EE, if it's really going to be multi-tenant SaaS with a lot of configurability, you may actually spend 30 to 50% of your time building those non-functional requirements before you actually start building your business functionalities. So that's the disadvantage of ground up development, but a lot of advantages because you get a lot of flexibility and control. If you are an architect, you would love this because you really have full control over the entire application stack. Okay, and another interesting aspect is there when you're a startup or you're an ISV and you are trying to value your company for selling or merger. If you have built your application on a third-party proprietary development environment, the valuation is much lesser. If you own the entire application stack, your valuation is much more higher. So that is one more criteria that investors and CEOs look for when you recommend them a solution in terms of how you build your multi-tenant SaaS application. Okay. Now I just had two more slides. What is this third approach? Like, I'll just go back and just show you that. So we have already talked about these two approaches. The typical ground up development or using an existing PaaS like APaaS like Force.com or Orenscape versus this, the third alternative. Third alternative is you need to get the best of both worlds. You need to get the freedom, flexibility and control that you are used to in .NET development. That you, as an architect or as a developer, you need a lot of control and flexibility to build complex applications. At the same time, you don't want to waste, out of 100 people months project, you don't want to waste 30-40 people months on building non-functional requirements. So you would rather spend 50-60 people months on building the business functionalities and use the SaaS application platform for the non-functional requirements. So that's the trade-off. So you get the freedom and at the same time you save time and cost and you reduce the risk. Because the risk comes from the fact that not all developers are uniformly experienced. The consistency will not be there. So if you are going to use a lot of developers to build a multi-tenant SaaS application ground up, there's a lot of risk involved in their ability to engineer it and architect it properly and do the right kind of robust, even though an architect may be there still. So it's always better to have a layer which which enforces certain type of an architectural blueprint required for cloud, SaaS, and multi-tenancy and scalability, performance, etc. So that your developers can only focus on building the business functionalities. Even if they are just 2-3 years experience, they just can build only the business functions. Okay, so that is the advantages of. So you get to use a 3GL development like .NET. You can build the business functions on top of the platform. You can use it for multiple products. For example, you are planning to have 3-4 different products in your organization which have to be migrated to cloud and SaaS over a period of time. You can use the middle platform that I talked about for multiple products. So you have a common layer which is used across multiple products, which makes the maintainability much more better and easier. And of course the platform has to be loosely coupled from your business functionalities, so that you can independently upgrade the multi-tenant SaaS platform without affecting your business functionality. So if you're already on production, you're running an application, let's say 1,000 customers are using it, can you upgrade the middle layer with some additional features without disturbing your business functionality? So that there is a huge difference between the second and the third approach, because this is a monolithic stack. So every application has its own monolithic stack. If you have 4 products, you have 4 such stacks. So if you have to upgrade, you have to upgrade each one of those applications. Whereas the third alternative, you might have 4 different products, but the middle layer is common. So you upgrade the middle layer, all the applications in your company gets the benefit of that upgrade. Okay, so this is a typical stack. Okay, so the bottom is a technology stack, like let's for example .NET 4.0. Of course below that I'm not showing is your Windows Server, your SQL 2008, or if you are hosting on Azure, it is SQL Azure. If you are using Amazon RDS, it is going to be Amazon RDS or MySQL. So that's your underlying infrastructure. You have .NET 4.0, let's for example, is a technology stack. The top is your product specific functionality. You might be building a CRM application, a finance application, any sort of application, okay, which are business functionalities. These are the non-functional requirements that I talked about, starting from caching, auditing, exception handling, all that is part of the stack. You have application level multi-tenancy, isolation of data between customers, because no customer wants their data to be exposed to other customers. Okay, so there is data isolation required. User management, roles, privilege mapping, because the policies, each organization that you're selling to, your application as a service, will have a different security policy, access control policies, and they want to customize their access control policies for their organization. And so you should be able to runtime configure the roles and privileges for each user for different customers differently without changing your underlying code base. So that is part of roles and rights management. Configurable UI, like the logo, the themes, even what columns are displayed in a grid, what fields are displayed in a form, whether it is required, not required, compulsory field, not compulsory field. Most of these things customers want to customize for their organization, but you can't keep changing the code for that. So you need to be able to have the configurability on the UI and the reports and custom fields, adding new custom fields for every customer. Okay, so all that has to be built in your non-functional layer, non-functional requirements. Another interesting area is, like for example, you're building a leave management module, let's say a performance appraisal module. The workflow of who approves it, who then rejects it, and where it goes, etc., will vary from organization to organization. Okay, so all the human workflow based systems have to be customized by different customers differently. So a typical workflow tools like Microsoft Workflow Foundation will help you as a developer to design workflows and incorporate them. But if you want to expose that to an end user on a browser to customize the workflow, it's very difficult. So you need to build those capabilities so that you expose part of these workflows to the end user to customize. Let's say HR manager can go and customize the workflow for their organization, or the business rules. Let's say a benefit administration product, the eligibility conditions for applying for a Mediclaim policy could differ for different organizations, which a non-IT person like a HR executive should be able to go and customize in an application. And if you are going to write code for all those customizability in your application, it's going to be a huge overhead. Whereas a standard platform will give you all those capabilities right out of the box. So you inherit the forms, you inherit the grid, you inherit the entities above the platform, which is loosely coupled, so that when you build your product on top of this, all those capabilities automatically accrue to your application. And then there is the operational things like license management, package management, what is common across applications like CRM, finance, HR, any domain, any application. There are certain things that are common like user management or license management or package management, authentication, security, etc. So all this can be coming out of the box for you from a ready to use, easily upgradable platform, so that your developers can focus on the business functionalities. So I'll stop here. If there are any questions, I'll answer them.
Hi. So I have a question like for a startup, when you are thinking about developing a new application, your focus is to just get the application right, test it out in the market quickly. So you would probably like to use the alternative where you're only focusing on the top layer, that product specific functionality. But as you grow, as you get more established, are there any milestones you can look when to switch from alternative 1 to alternative 2 to alternative 3, so that you bring in more and more of the stack in-house?
Okay. See, if you are trying to prove your business model to your investors, for example, okay, so yes, they are the first 10 customers, 20 customers, you don't even have to build a multi-tenant application, okay. So you can still afford to have a separate server for every tenant on Amazon, okay. So multi-tenancy is really an issue only when you are really successful and you want to grow, okay. So you can actually build a normal web application and still go on a single tenant model, which means there is a separate instance for every customer to prove your business model. That is one approach. The other approach is to go to a PaaS solution like Force.com or Orangescape and quickly build a prototype, put it out in the market and ask customers to use it and see whether they are willing to pay for it. And once you are convinced that there is a market for this product, then you can always directly go to alternative 3 and take a stack and build your business functionalities on top of that, okay. So depends on your application, depends on your scenario. Both these can be tried if you are a startup.
I just wanted to know how long it will take to integrate from an existing application for any typical application with this the multi-tenant layer, whatever you are telling, right?
Okay. So. See, for example, if this is actually typically a layer from a .NET stack. So if you already have a .NET application and you need to because if it is a 5-6 year or 7-year-old application and you have really not built the MVC approach to separating your layers, it's very difficult to migrate. It's better to rewrite. But suppose it's just 2-3-year-old application and you already built it on MVC, then it might be much easier to introduce this layer between your product functionality and the underlying infrastructure and go. So it's a little bit of messaging required on your code to make it go through this layer instead of directly going to the database or directly going to the infrastructure. So it depends on the maturity level and the age of the existing application, whether you need to, how much of it can be reused. I would say if the reusability is only 30-40%, I would definitely say rewrite it from the scratch. The reusability is something like 50-60% or 70%, then it's better to migrate it, modify the code and take it through this stack.
Okay. Also, who will manage this layer in public cloud? Suppose because I have to build my application with this layer, right? So once I developed it and after I hosted in the public cloud, so who will manage these layers?
Actually, in our case, see, different approaches are there for different people. There are people who offer this as a service on the cloud, which means that we are also planning to offer it as a service on the cloud eventually. But as of today, what we offer is a library of components or a framework, which is as a package delivered to you, which you use during development and deploy it wherever you want, which means the binaries of this layer is already deployed along with your binaries. Now in terms of maintenance, you have two approaches. One is to get an AMC for this so that the upgrades and maintenance is automatically taken care of by the vendor of this stack, or you can license the source code of this stack if you are confident, and then integrate it with your application and then maintain the entire stack yourself, including the source code of the stack. So both the options are available. Okay.
Also, I have one more question. Is there any integration with platform management tools or monitoring tools, such kind of tools for the SaaS application?
No, there is. This is actually, of course, supports WCF services based approach, which means that integration with external services. It could be the services provided by the cloud provider, it could be the services from an existing on-premise application of your tenant. Let's say your customer has an existing HRMS and you want to integrate your application with their on-premise application. So integration is always done through services, it is possible.
I have a question.
Yeah?
Within the stack, do we have flexibility to choose native brands? For example, for rules engine, you choose rules, and for UI, you choose GWT. Can you make a choice of the vendors, or?
Yes, if you, for example, UI, if you want to use Silverlight or if you want to use Flex, and you want to only use the middle layer, then you can use it as only consume the services and use your own UI controls, and your own UI you can choose. Similarly, if you want to use certain components, not use certain components, you have the option. Not compulsory that you should all the components. It's entirely a library API based approach. So it depends on where you want to use, where you don't want to use. It's entirely in your control.
If a project is developed in PaaS, so the flexibility of increasing the number of customers. So based on that bandwidth or whatever the flexibility, it can be done on the fly. So if it comes to the ground up model, so it will be deployed in a virtual machine, something like that, right?
So it can be again a cloud, Amazon or Azure, where the same scalability will be there. For example, you can either have a manual scale up, scale down, or an auto scale up, scale down, where you integrate with the APIs of the cloud provider. Where if you say a particular, let's say you're using CloudWatch as a tool, and you are saying that at a particular load, you want to spin off an additional instance, it is possible. So what this kind of platform assures you is that this design is stateless. The database is partitionable both horizontally and vertically. So if you want to scale up, scale down, both manually or automatically, it is possible if you have built it using this platform. You don't, because the developers during development, they wouldn't have bothered about scalability or where the data is located, etc. The platform will take care of it. Okay, but yes, it is possible to scale up, scale down, both automatically and manually, if an application has been built using this kind of a stack. Except that you need to build those deployment automation tools. So this doesn't come with the deployment automation tools. So you have to integrate your application with the necessary deployment automation tools to spin off an additional instance, for example, whenever there is a need. Or you can manually do that. So from an architectural point of view, it is possible, but from an actual operational point of view, whether you do it manually or whether you integrate with the deployment automation tool is your choice.
Vertical scaling up, there is some limit, right?
Yeah, vertical scaling on the infrastructure is a limit, but there is something called as I am talking about the database partitioning. There is a vertical partitioning and horizontal partitioning, which is supported, which means that you can actually separate databases. Like you can have one large customer in one database, 100 medium-sized customers in another database, and 1,000 small customers in another database. That is horizontal partitioning. Vertical partitioning means you have, let's say, 5 modules in your product, and module 1 and module 2 is in one database, and module 3 and module 4 is in another database. Okay, that is called as vertical partitioning. Okay, so this platform supports both horizontal and vertical partitioning on the database. So you can scale out your database as you grow your business. Whereas this scale up, scale down in terms of number of instances, you can vertically scale up a particular instance, or you can spin off an additional instance, or keep adding more instances. Like you can even go up to 25, 30, even 50 instances, all through a load balancer. And even if a customer has logged in and is using the system, and the load has increased and you have spinned off an additional instance, and this user is being redirected from now this instance to another instance, the user will never know. Okay, so whether your underlying stack has been designed to seamlessly transfer a user from one instance to another instance without the users being aware of it, it requires a lot of engineering and architectural excellence in the way you have built your code. So that is taken care of by the platform.
Okay. Is there any benchmark to increase the number of instances, application instances?
Depends on the concurrent users, so depends on the hardware you are choosing and RAM you are choosing, and there are benchmarks like every 500 concurrent users you spin off an additional instance. That is standard. It's applicable for any .NET application, which is using, let's say, SQL database. So there are some standard benchmarks. So there's no different here.
Thank you.
Thank you.
Thank you so much, Mr. Ramkumar. Now, we'd like to present Mr. Ramkumar with a small token appreciation on behalf of UBM.